Students, in this video I am going to discuss the next method, which is modified Euler's method and also known as Hume's method. Fine. So this is the problem: dy by dx is equals to f of xy, and the initial condition is y at x naught is y naught. This is equation number 1. Fine. So here if you will see in this graph, this is the exact curve, and this blue line, straight lines, they are nothing but the Euler's method, existing Euler's method. Fine. In Hume's method or modified Euler's method, basically we first predict the value with the help of Euler's method. That means first step is to just predict the value. So this value is predicted with the help of Euler's method. For example, here this value is as same as Euler's method, but then this value is corrected with the help of modified Euler's method, in which we will take the average of two consecutive slopes. Here the slope at x naught y naught is this, and this is the slope at x1 with predicted value, first predicted value. Take the average. So this is the first correction. Then again we will use this value herein, and then again corrected the value. So y1 third approximation is y naught plus, so you just take the average. So that's why this is the first predicted value. Then the value is corrected here by taking the average, then again corrected. So here is the same, except this point here is y11, here is y12, and so on. This procedure is done number of times to get the desired accuracy. So here this is the n plus 1th approximation of y1. Fine. So this is Euler's method. Once y1 is evaluated, then we will again use this value to predict y2. So y2 first approximation with the help of Euler's method, and then again corrected with the help of modified Euler method, this taking the average y11. So this is the n plus 1th approximation of y2 is equals to y1 plus h by 2 f at x1 y1 plus f at x2 y2 n, where n is 1 to 3. So this is the general formula, but here this is first we have to predict the value and then corrected with the value. So that's why in this formula, Euler's modified method, we have to use these two formulae. First, this is for prediction, and this is second formula is for the correction. This is for prediction, this is for correction. Fine. Similarly, this is the prediction, and this formula is for the correction. Similarly, once you are evaluated y2, then use this to predict the value. This is the prediction, and then correct the value. So this is the correction. So this is modified Euler's method. I think you understand the method now. Now we will have example. So this is the example. Differential equation is this: x plus square root of, this is modified Euler, not improved. This is modified. Fine. This is modified Euler's method, also known as improved, but here I am using term modified. So dy by dx is x plus magnitude of square root of y. Y is 1 at x is 0. So this is x naught, this is y naught. Step size is 0.2, and then find out the solution in this range 0 to 0.6. Fine. So basically we have to find out the values x naught, x1, x2 and x3. This is equal to 0, this is equal to 0.2, this is equals to 0.4, and this is equals to 0.6. Here the value is already given to you 1. So here we have to find out the value. So first predict the value. So this is the predicted value with the help of Euler's method. So this is the prediction. y11 is equals to y0 plus h f at x0 y0, which is equals to 1 plus 0.2, and x f is this function x plus this. So this is the x0 plus magnitude of square root of y0. Substitute the value, we get 1.20. So this is the prediction. Now the value is corrected here. So y12 is y0 plus h by 2, f at x0 y0 plus f at x1 y11. First predicted value. So 1, y0 is 1 plus h is 0.2 by 2, x0, this function is x0 plus magnitude of square root of y0, plus f of x1 y11 is x1 plus magnitude of y11. y11 is this 1.20. So substitute the values. So finally we get 1.2295. Similarly, now use this to get the next approximation. y13, this will be 1.209, and so finally you will see that here these are correct up to only first decimal place. However, these two are corrected up to fourth decimal places, so they are same. So that's why stop it here, and that's why this is the solution. Fine. So at least you have to find out the solution which is correct up to third decimal place. Similarly, you can find out the y at 0.4. So this is here, you can easily understand the calculation. We will provide the notes. So this is y21. First we will predict the value and then correct the value. Fine. So this is the procedure, and then once you have evaluated this is the second correction, this is the third correction, and you will see that here third correction and fourth correction are almost same. That's why this is the value of y2. Now we will use this y2 to find out the y3. So this is the prediction with the help of Euler's method, and then this is the first correction. This is the corrected value. So here we have taken the average. So 1.8849. This is the third iteration. 1.8861. Fourth iteration is this. So both will be same. So this is the value. So ultimately we have evaluated all the desired values y0, y1, y2 and y3. Fine. So this is the procedure how to find out the value with the help of modified Euler's method. Fine. So now in the next video we will discuss about the Range-Kutta method. Thank you.